In this video, we're going to be tackling the very popular LeetCode question, rotate image. What LeetCode wants us to do is they want us to take a matrix, a 2D array, a nested array, if you will, and they want us to rotate it like a clock 90 degrees. How is this going to work? So let's take a look at our before matrix. This is the matrix that we have not done any rotation to. What we're going to do is we're going to take these top three elements right here and we're going to translate them so they are now on the right side. And then we're going to repeat this process for every single side. So we'll take 369 and it's now going to be translated to 963 on the bottom. We'll take 789 and then we'll repeat this process so that the 789 is now on the left side. And finally, we will take this 147, we will translate it to 741 on the very top element, the matrix that we have translated. This process is going to be very similar or look very similar to if you took a Rubik's Cube and just turned it on its side, just like that. But here's the million-dollar question. How are we going to translate this into an algorithm? Well, we're going to use what are called swaps. You're probably already familiar with swaps. We're just going to swap each individual element, and we can actually do this with a nested for loop. So how exactly is this going to work? Well, this is an algorithm, so we're going to need iteration of some type, and what we're going to do is we're going to initialize a nested for loop. And within this nested for loop, this is where we're going to be doing our swaps on steroids. But before we start doing these swaps, what we're going to do is we're going to have to store one of our elements in a temporary variable. And the reason that we have to store one of the elements in a temporary variable is because when we do the last swap, it's going to overwrite the original. Now, if it doesn't make sense, it'll make more sense here in a second. Let's just go ahead and start doing our swaps. So we've already got our 7 stored. What we're going to do is we're going to take our 9 and we're going to swap it with our 7. We're going to swap the bottom right element with the bottom left element, and this is going to become a 9. Now we're going to do the same exact thing, but we're going to take our top right element and we're going to swap it with our bottom right element. And this is now going to become, you guessed it, a 3. And finally, what we're going to do is we're going to take our top left element and we're going to swap it with our top right. This 3 is now going to become a 1. Then what we'll do is we'll take our temp and we'll swap it out with our top left element. And you notice that I swapped it with the temp and not with the 9 because if we swapped it with the 9, that wouldn't make any sense. Remember, we are in a nested for loop, so this process is going to repeat once again, but it's going to shift over one element or up depending on where it is in the matrix. So instead of the temp being 7, it's now going to be 8. And we're going to take our 6 and we are going to replace the 8. We're going to swap out the 8 for the 6. Then what we're going to do is we're going to do the same exact thing. We're going to replace the 2 with the 6. The 6 is now going to become a 2. And we're going to replace the 4 with the 2. The 4 is now going to become a 2. And once we get to the final element, we're going to go ahead, we're going to swap it out for the temp. So this 4 is now going to become an 8. And we have successfully rotated this array. That is the algorithm. Now we just need to code it up. So let's go ahead. Let's hop over into IntelliJ. So we're inside of IntelliJ, and the first thing that I'm going to do is create a Java class, and I'm going to name it solution. Within this solution, we're going to have a method that is going to, number 1, return void. And this is very important to understand because we're going to be doing all of these swaps, all of these calculations in place. We're going to name the method rotate, and the parameters are going to take in a matrix that contains integers. We're not going to do any null checks because we're returning void, and we're going to go ahead and abstract out the length of the matrix so we don't have to keep typing it out. The next thing that we're going to do is we're going to begin creating our nested for loop, and the AI is going to handle pretty much everything for us, but there is one tiny mistake. The outer loop needs to be n plus 1 divided by 2. Now you notice that there is a division of 2 for the n. The reason that we're going to do that is because we don't want to go ahead and iterate through the whole entire matrix. We only want to iterate through half the rows and half the columns. And the reason that we want to do that is because if we're doing swaps from, say, 8, 9 to 7, we don't want to continue iterating because it's going to overwrite the progress that we've already made. And that's the reason that we're dividing by 2. So before we do any swaps, we need to go ahead and create our temporary element. Remember that we need a temporary element because when we do the final swap, if we don't have a temp, we're going to overwrite the last element. And in our previous example, this number was 7. Essentially, we want to store the bottom left element as the temporary variable. But how exactly are we going to access the bottom left? Well, let's have a little crash course on how we access elements in a matrix. We access them with double brackets. The first bracket means row, the second bracket means the column. And these are typically going to be filled with variables, but let's just say we want to access the very first element in the first row and in the first column. We would have double zeros, and this would have us access number 1. But how are we going to access the bottom left? Well, in our case, what we're going to do is we're going to have some fancy syntax. We're going to say the matrix length minus 1 minus j. And this is going to make it so that for our row, we're going to access the bottom row. And in the second bracket, we're going to have an I. And we're going to populate this with an I so that when we get done iterating through the outer loop, we just move over 1 to the right for our column. So we can finally start doing our swaps now. And in order to clarify things and understand what is going where, I'm going to leave a comment that says bottom right to bottom left. How exactly is this going to work? Well, we're going to use our fancy syntax. We're going to say n minus 1 minus j. And this basically means go down. But we don't want to go across with our column. We want our column to be on the left as well too. So we're going to leave the I. And this is where we're going to do the actual switch. This is where we're going to go from the 9 to the 7. And this 7 is going to be swapped out for the 9, just like that. And the way that we're going to do that is, well, AI pretty much did everything for us. We want to go to the bottom right. So we're going to go across, and we're also going to go across our columns, and that's going to lead us to the bottom right. So now we're going to go from the top right to the bottom right. And in doing this, we're going to be reusing the same matrix access that we had before. We're going to be using the bottom right. And in order to get to the bottom right, we're going to have to go down, and we're going to have to go across. So we're going to say n minus 1 minus I and n minus 1 minus j. And we want to swap it with the top right. How exactly are we going to do that? We're going to say matrix. Because we want to go to the right and not down to the bottom, we're just going to have a j right here. And then we're going to have n minus 1 minus I. So the next swaps are going to be incredibly easy. We're going to go from top left to top right. How exactly are we going to access the top right where we want to store the element? Well, first things first, we're going to be staying on the top row. We don't want to go across, so this is going to be a j. But we do want to move to the right, so we're going to say n minus 1 minus I. Finally, how exactly do we access the top left element? Well, this is probably the easiest one to access out of all. We don't need to move anywhere. We don't need to go across anywhere, so we're just going to say I for the first bracket and j for the second bracket. Then we're going to go ahead, we're going to go down, and this is where we're going to move our temp element to the top left. Just for old time's sake, I'm going to say temp to top left, and what we're going to do is we're going to go ahead, access the top left, and go ahead, store our temp. Congratulations, we have hopefully solved this algorithm. So what I'm going to do is I'm just going to go ahead, copy all this, let's get out of full screen view, and let's get LeetCode opened up. So let's go ahead, let's pull up LeetCode. We're going to go ahead, toss the code that we just created into the editor. Let's go ahead, smash that run button. All of our test cases passed. Thank the Lord. Let's go ahead, smash that submit button, and let's check out our time complexity. So time complexity, LeetCode is going to say quadratic, but that is arguably going to be n because the amount of times that you're going to iterate is going to equal to the amount of elements in the matrix. Also, let's go ahead, make sure our time complexity is constant because we do want that constant space complexity. Anyways, hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button, and as always, thank you for watching.